Okay, for the multiplicative inverse, let's review the multiplicative inverse of a regular number first. Let's say you have the number 2. The multiplicative inverse is the number we can multiply by 2 to make the answer 1. So, for example, 2 times a half equals 1. So those are called multiplicative inverses. 3 over 7 times 7 over 3 equals 1. Negative 2 over 3 times negative 3 over 2 equals 1. Those are all multiplicative inverses. The multiplicative identity, so 3 times 1, for example, is 3. The 3 keeps its identity, it stays the same. So the multiplicative identity of a number is 1. The multiplicative identity of a matrix for a square matrix is always like this. We have 1. And then to find the multiplicative inverse of a matrix, we're going to use this formula. So let's say we have matrix A, B, C, D. And the A determinant, remember those absolute value bars represent determinant, cannot equal 0. And here's why. Our formula is 1 over the determinant of A. You cannot have 0 in the denominator. So if that happens, it's undefined. And it does not have an inverse. And then you would put D, negative C, negative B, A. Okay, you will notice what happens here is we switch the D and the A. Those flip around. Then the C and the B, we just change the sign. And then you multiply it by 1 over the determinant, or the reciprocal of the determinant. Okay, so now let's look at some examples. Okay, first we're going to see, does it even have an inverse? To do that, let's find the determinant. So we multiply the diagonals and subtract. So you have negative 7 times 6 is negative 42. We subtract. 21 times negative 2 is also negative 42. So that equals 0, which is undefined. So that would be no, it does not have an inverse. For the other example here, we do 6 times 4, which is 24, and then we subtract. And then negative 3 times 8 would also be negative 24. So when you add those, you get 48. So yes, that one has an inverse. So now, let's look at how we find an inverse. First thing we need to do is we need to find the determinant. So take our first column here. Negative 9 times 1 is negative 9. Then we subtract. Negative 4 times 5 is negative 20. So that gives you 11. So 1 over 11. And remember, we switch the A and the D. So the 1 moves up here. The negative 9 moves here. And then B and C stay where they are, but we change the signs. So the 5 changes to negative, the 4 changes to positive. Now we just distribute the 1 over 11. So 1 times 1 over 11 would be 1 over 11. 4 times 1 over 11 would be 4 over 11. Negative 5 times 1 over 11 would be negative 5 over 11. And then negative 9 over 11. So that is your multiplicative inverse of that matrix. Okay, for this example, we need to first of all find our determinant. So multiply across that diagonal. So 5 over 12 times 2 over 3. 2 goes into 12 6 times, so that's 5 over 18. And then we need to subtract. You have negative 1/3 times negative 7 over 12, which is actually 7 over 36. So 5 over 18, or 10 over 36, minus 7 over 36 equals 3 over 36, which reduces to 1 over 12. So if you have, for our formula, we need 1 over A. So 1 over 12 actually equals 12. Then here, remember we switch A and D, so the 2/3 moves up here and the 5 over 12 moves here. The B and the C stay where they are, but we change the sign. So 7/12 changes to positive, 1 over 3 changes to positive. Now we distribute the 12. 2/3 times 12 is 8. 1/3 times 12 is 4. 7 over 12 times 12 is 7. And 5 over 12 times 12 is 5. So that would be your multiplicative inverse. Okay, we can use inverses to solve a matrix equation, just like you can use inverses to solve an equation like this. The inverse of 5, or the reciprocal, is 1 over 5. So those cancel, leaving you with x equals 2. We're going to do the same thing over here. We're going to find our inverse and then multiply each side. So to find the inverse, first of all, we need to find the determinant. So multiply your diagonals. 7 times 3 minus 5 times 4, so that equals 1. Remember, our formula is 1 over the determinant, which is 1. And then we flip the A and the D, so 3 moves up, 7 moves down. The 4 and the 5 become negative. And of course, when we distribute the 1, it stays 3, negative 5, negative 4, 7. So that is our inverse. So now we're going to come over here and we're going to multiply each side by the inverse. Now it is very important to put the inverse first. We always do it that way. Multiplication of matrices is not communicative, so the order is important. If you try to do it the other way, it's not going to work out for you. Okay, so we know over here that these are going to cancel because they're inverses, so that's going to become 1. So we just have x, y. Now, let's review multiplication. We know here we have a 2 by 2, 2 rows, 2 columns, and then here we have 2 rows, 1 column. Remember, these need to be the same to multiply. They are. We can cross those out. So our answer is going to be 2 by 1. I said 1, and I wrote 2. Okay, 2 by 1. So to find our top row, we take our top row, multiply by the column. So 3 times negative 10 plus negative 4 times negative 6. Then for the bottom, we take the bottom row, multiply by the column. So negative 5 times negative 10 plus 7 times negative 6. And then when we simplify that, 3 times negative 10 is negative 30 plus 24, that would be negative 6. Here we would have 50 minus 42, so that would be 8. So x equals negative 6 and y equals 8. Now we can use that concept to solve a system of equations. So to write this system as a matrix, it would be 8 over 9 and then 6, 7, x, y equals 2, 1. Okay, so first we need to find the inverse. And to do that, we need to find the determinant. So we first find the determinant. So to do that, 8 times 7, which is 56, minus 6 times 9, which is 54, so that would be 2. So we do 1 over 2. Remember, we need the reciprocal of it. Flip A and D. Change the signs of B and D. And when you distribute, you have 7 over 2, negative 9 over 2, negative 3, and 4. So there's our multiplicative inverse. So we're going to come up here and multiply each side by that inverse. And remember over here, we need to put the inverse first. So on the left, we know those are going to cancel and be 1, which will leave us with x, y. Let me do that a little bit smaller. So over here to multiply, again, we have a 2 by 2 and a 2 by 1. These are the same. So our answer is going to be a 2 by 1 again. So 2 rows, 1 column. So for the first row, we multiply our first row by our column. So 7 over 2 times 2 plus negative 3 times 1. And then for the bottom row, do the bottom row times the column. So negative 9 over 2 times 2 plus 4 times 1. So when we simplify that, 7 over 2 times 2 is 7 minus 3, which is 4. 9 over 2 times 2 is negative 9, plus 4, which is 5. So x equals 4, and y equals 5. And so that's negative 5. Negative 9 over 2 is negative 9 plus 4 is negative 5. So x equals 4, and y equals negative 5.